All right, YouTube, we had a nice little introduction there. Also memorize that definition of a function, relation which every element of the domain corresponds to exactly one element of the range that will be on your test. Memorize it perfectly. Now that we have this function, let's practice function notation. We want to be able to identify f of -3, f of 0, f of 2, f of a, and f of a minus b. So this is notation that the mathematical community kind of put together to say, how do we want to say that we want to identify the output value with the given input value. So they replace the x with a -3, and so wherever you see an x, you place in that domain value. So we get an output of -14. Plug in 0, we have 3 times 0, minus 5, -5. F of 2, 3 times 2, minus 5, 1. What about f of a? Yes. F of a minus b. Three a minus 3b minus 5. So you might wonder what value is there to plug in variables. We will actually do it a lot. It's really important for calculus sake. Please do letter B and try to identify all those, okay? And we'll see if we come up with what I got. Okay, here we go. Any questions on those? 15, 0, 0, a squared minus 2a, and then a squared minus 2ab plus b squared minus 2a plus 2b. Any questions on those? Okay, so you practiced that before, haven't you? Okay, and you have a reference for your learning there. Whereas letter C or D, that looks completely different, doesn't it? See, we're going to investigate what are called piecewise functions during this unit as well, which means you can have a function that looks like this. You guys are used to plugging stuff in for things that look like that. But what if the function looks like this? You know, you can have functions that are broken into pieces. And that's what we have here. So let's say we want to identify the function value for a given input. Instead of using the a's and the b's, we're just going to do f of -3, we're going to do f of 0, we're going to do f of 2. So it says that f of x is actually equal to two different things. So how do we know where to plug the -3 into? Do we plug in the top one or the bottom one, or do we do both? What do you think? You see there's this nice condition off to the side. Notice this semicolon. It says we're going to use 2x minus 1 if x is less than 0. And we're going to use -1/2 x squared minus 3/2 x if x is greater than or equal to 0. So which one does -3 satisfy? The condition for the top one or the bottom one? The top. So therefore we plug it into the top. When I do that, I get -7. Then, which condition does 0 satisfy, the top one or the bottom one? So we get 0. And 2 also satisfies the bottom one. So we get -2 minus 3 is -5. Any questions on that example? You try letter D on your own. Don't do A and B stuff, just do f of -3, f of 0, and f of 2. I have 4, 18, and 16. Is that what you got? That middle one's kind of weird, isn't it? That means that no matter what I plug in, the output is always 18. Anybody know what that looks like if I were to graph it? I'm sorry, anything that I plug in between -1 and 2. You're right. You can't plug it into somewhere, meaning that you don't have an X value. You must really like this class. All right, here we go. So, um, Grace, this is what the graph looks like. It's a horizontal line that travels through 18. So you're absolutely right. If you have y equals 18 and you have an x value of 2, there's no way for that 2 to affect it. It's just always 18, no matter what. And that's what we have. Let's flip it over, okay? Now comes into play an example where we're actually going to plug some letters in. I do this, and trust me, especially for you juniors who will take calculus next year, this is extremely important for you. This really helps you as you move towards the next year. We have find f of a plus h minus f of a all over h. So that now becomes our rule that we're trying to satisfy. Okay? In order to do that, I'm going to break it up into two parts. First of all, I'm going to find out what f of a plus h is. That means I plug in what for what. I replace x with, so I have a plus h quantity squared. Everybody okay with that? All right, now I'm going to write f of a. What is f of a? A squared. Everybody okay with that? So now I'm going to write out the rule that I'm trying to simplify. It says f of a plus h, which is a plus h squared, minus what? A squared all over h. Now, what's interesting about this, and we don't really know why, you guys were practicing this to really help you in the future, okay? We want to be able to simplify this, and what's always going to happen is this. The h on the bottom will always disappear. Always. Every single time. Watch. If I multiply a plus h squared out, what do you get? So what's nice is everything that doesn't have an h attached to it will find a way to cancel. If it doesn't, you did something wrong. So what cancels? The a squareds cancel. What can you factor out of the top? Times 2a plus h divided by h. H divided by h is 1. So we're left with 2a plus h. That's my answer. The h that sits in the denominator will always divide off. Everything that didn't have an h in the numerator will always cancel. Let's do one more example. And trust me, guys, we spend 2 days on this. I'm just giving you a brief intro so that tomorrow goes better. And trust me, it will for you. So let's write this out. G of a plus h. What is g of a plus h? 2 times a plus h. Can you understand that some people might forget to write the minus 3 on the end there? That's a mistake that sometimes comes up, so be careful of that. Now I'm going to write g of a. That will be 2a minus 3. Right? So same thing, except instead of f, it's just g. So g of a plus h be 2 times a plus h minus 3. Then what? And I'm going to put a parenthesis around that because I have to distribute the subtraction sign all the way through. All over h. Let's write out the numerator. We have what? Everything that doesn't have an h should cancel. Does it? The 2 a's cancel. The 3's cancel. And you're left with 2h over h. What is 2h over h? 2. Kind of neat, huh? The examples get a little bit more difficult, but we're going to pick up with those tomorrow. Right now, I leave you with this as an assignment. 11 through 16, 21 through 24, 29, 30, and 33. I do not have the book pages online yet, and I sub next hour during my prep. So therefore, I'll put them on right at the end of school, okay? Just note that 29, 30, and 33 are kind of like what we practiced here right now. And you might not fully understand them. And don't worry, we're going to practice again tomorrow, okay? But the other problems, I think you should be able to do just fine. So 29, 30, and 33, where I have the question mark right here, that might be a little bit more challenging. I should put it on here so people can see it. My bad.